Now we are going to apply what we just learned about solving for a missing measurement in a formula with a few problems that we did or we're going to attempt to do on the Day 25 packet 7.2 guided practice. So at this time I would like for you to push pause, get out your Day 25 packet, and turn to the 7.2 guided practice. There were two problems I asked you not to do yet because I had not shown you at the time how to do those types of problems. We're going to go over those together today. When you're ready, push play. Alright, I know you've probably already did problem number 5 yesterday or in the previous class, but we'll go ahead and do it together today just as a refresher. The question says the height of the rectangle is 23.54 centimeters and its base is 34.67 centimeters, and it asks what is the area. So the key words here when you have a story problem is ask yourself, what am I looking for? The question asks, what is the area? Well, then you got to say, well, area of what? Each shape has its own formula, so you need to read back through the question and look for the name of the shape that we need to get the formula for. In the question it says the rectangle. Okay, so we need to write down what is the formula for area of a rectangle. Area of any rectangle is area equals base times height. Then we look back through the problem for any of these variables that we are given. It says the height is 23.547, so that's that number there. I'm going to go ahead and write it, 23.54. We need to figure out what the base is. Well, they tell you is 34.76. What we don't know is the area. So this problem right here is pretty straightforward. There's no x for us to solve because the variable we're looking for is already by itself. So all we need to do is multiply 34.76, I think it looks like a 2 that I wrote there, but that's supposed to be a 7, 76 times 23.54. Go ahead and use a calculator right now, it's okay. I am. In my calculator, I got 58.3. But I'm not done yet. This is a story problem. 58.3 what? On the Algebra ECA, you must label any answers or give the units of any answers that are a story problem or a geometry problem where they tell you what the units are. So it says centimeters and centimeters. Area is measured in square centimeters. If they give you feet, it'd be square feet. Things. So the measurement is the centimeters squared because they asked for the area. Had they asked for either the height or the base, it would have just been centimeters. Let's look at problem number 6. I'm going to zoom, well, I was going to zoom in for you. I think I'm going to have to clear off some space so that we have room to work or room for me to show you how to solve this problem. Okay, I made some white space above the problem so I can show you how to do the work. If you have a scrap sheet of paper, you can use that because this little area between the two problems may not be enough to work out the problem. Alright, let's read the question. The local pool is considering adding another kiddie pool. They only have a circular area of 314 feet squared. What is the diameter of the pool? So they're talking about a circle shape. Let's go ahead and draw the shape that they're talking about so that we can figure out what we're given. So we have this pool here. They tell us that the area, or the amount inside, is equal to 314 feet squared. But that's not what they want to know. They want to know what is the diameter. Well, how would we draw a diameter of the circle? Remember that diameter is the distance all the way across a circle, and it has to go through the center point. So what we don't know is our diameter, the distance all. That makes it look like I want the radius. I'm going to put it right here in the center to let you know that I want it all the way across that circle. So what is the formula for area of a circle? We need to use that. Area of a circle equals pi r squared. Let's plug in the information that we're given. Area is 314. Pi is just part of the formula. We don't know the radius. It just gives an x squared. So we have to first divide both sides by pi. Sure would have been nice if that was 314 pi so that the pi's would cancel on the left side of the equation. They do on the right. So now you need to use your calculator and find out what 314 divided by pi is. Use your pi button on your calculator. When you're done, do not clear your calculator out. Leave it where it is. It's going to have some great big long decimal. That's okay. So 314 pi, what do you get? I'm going to use my calculator here. 314 divided by pi. Wow, that's a great big decimal. 314.1579. Leave that in your calculator for the next step. So it's like 3.4 da 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 da. We're not going to write it all out. But let's talk about what would we do next. Whatever that long decimal is, it's equal to x squared. So how would I get rid of the second power? I would have to take the root of both sides. So that's why I said don't clear your calculator out yet. You're going to take the square root of that number. It's already in your calculator. You just need to take the square root. Again, I'm going to show you my calculator. And on my calculator, the square root button is, let me look, where is it? If you're using a computer calculator, I see two buttons that have the square roots. Oh no, there's the one that's just the square root. These are just slightly different. This is any root. So you need this button right here if you're going to use the computer's calculator. And you get 1.72 blah 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 blah. Really long decimal point, right? Let's just round it to the nearest whole number. Or actually 1.72. Let's see, let's take it out to do 2 decimal spots. Let's see how your rounding is. If we have 1.7724 whatever, and I want to round it to this to the hundredth spot, what would that be? Well, my hundredth spot is that second 7. What number came before it? The 2. Well, 2's not higher than 5, so it would just be 1.77. And then they want to know the diameter. Diameter is just a linear measurement. So we would just say feet. 1.77 feet. Not feet squared. That's only for area. 1.77 feet is your final answer. I'm going to do one more with you, and then you have the rest for your homework. 10 problems, but in this case, you're just going to answer the 10 problems. You don't have to keep redoing them. Now, if you see that you're missing a lot, when you type in your final answers, you can always have your instructor reset the assignment for you. So let's do the next problem. Okay, I'm in some workable space here. Read the question. Ed has a swimming pool in the shape of a square. Stop right there. Let's draw a square. There's something about story problems in geometry. They really like swimming pools. There's a lot of problems that involve them. The bottom of the pool has an area of 500 feet. Now, don't be confused by the word bottom here. They're referring to, if you're looking from the sky down at the bottom of your pool in the area, they still mean the inside. the area of 500 feet. So we're given area equals 500 feet squared. If the length is 25 feet, what is the width? Also, find the perimeter of the pool. This is a two-step question. So they first ask us, what is the width? And they give us the area. And then they want to know, what is the perimeter? Well, let's do one problem at a time. Before we calculate our perimeter, let's figure out what the width of this pool is. Now, I'm going to give you a helpful hint. It says that the shape is a square. They give you a length of a square. What would the width be? Do you even have to use that area formula at all? No. Remember that all sides of a square are the same. So the width is also just 25. That was pretty easy. Okay, so let's go to the last part of the question. It says find the perimeter of the pool. Remember perimeter plus, that's when we have to add up all the sides of the square. Well, we have 4 sides that are each 25. So you can think of it as 25 plus 25 plus 25 plus 25. Or remember that a square is simply all 4 sides of equal length multiplied together. So 4 times 25. I know it. You know what 4 times 25 is. Please, none of you get out a times table right now. I know you know this. A quarter is worth 25 cents. How much do you have if you have 4 quarters? $1. Okay, so 4 times 25 is 100. And what did they want to know? The perimeter. So 100 what? Well, if the original measurements were in feet, so is the perimeter. It's 100 feet. Not 100 feet squared. That's only for area. Okay? I'm confident you can try doing these next problems. They're not going to be super easy, but you can do it. Go ahead and do the 7.3b homework, and that will conclude the lessons for today.